Hello, this is Mrs. Dubois, and I'm going to video an answer key for Practice 3, Math 8 on solving systems by elimination. So problem 1 is a real-life application. The Glee Club needs to raise money for the spring trip to Europe, so the members sell muffins and pies. On the first day, they sell 13 muffins and 12 pies for a total of $85. On the second day, they sell 13 muffins and 13 pies for a total of $91. Let's use the systems of equations to find out how much the Glee Club is charging for each muffin and pie. All right, as we have done in the past, we are going to draw a visual to represent that. So we're talking about muffins plus pies. And on the first day, there were 13 muffins and 12 pies, and the total was $85. This is going to be my representation for day 1 of the Glee Club sales. And then day 2, again, they're trying to raise money by selling muffins and pies. And on day 2, they had 13 muffins and they sold 13 pies, and it was a total of $91. Now the question is asking, how much are they charging for each muffin and each pie? So we need to define our variables. Let x equal the price of muffins and y equal the price of pies. Okay. The first equation represents my visual drawing. 13 So it's 13x plus 12y equals 85. And on day 2, 13 muffins plus 13 pies equals $91. Now I brought it down here so that I can solve the systems. And remember, we're doing this by elimination, which means we're trying to wipe out or eliminate one of the variables. Okay? So in order to do this, as this problem stands, we cannot add these two lines and wipe out one of the variables. So what we're going to do is we're going to multiply everything through here by -1. This will give us negative 13x, and you have to multiply everything by that -1, minus 12y equals negative 85. And then our second equation will be 13x plus 13y equals 91. And I'm just copying that one over. Now I'm ready. I can add these two together and wipe out or eliminate one variable. So I'm going to lightly, negative 13 plus a negative 13 is 0. So I'm going to lightly cross that out because I want to always be able to go back and read what I had. Then we're doing negative 12 plus a positive 13, which is 1y. And then negative 85 plus 91 is a positive 6. So y is equal to 6. Okay. Now the next step, which carries us up here, is to plug in 13x plus 12y equals 85. Oops, 85. Okay. So now we're going to plug in what we know. We know y is equal to 6. And we're using our parentheses because we want to make sure that it's in the bag. And then we're going to simplify the left side of the equation. 12 times 6 is 72. So we have 13x plus 72 equals 85. That's a two-step equation. We're going to subtract 72 from each side. Lightly cross that out because that gives you 0. And then you have 13x equals 13, which when we divide, x is equal to 6. Oh, sorry, x is equal to 1. So our solution there is 1/6, okay? Because remember, it's a systems of equations, and so we're looking for an ordered pair. And so we have to have an x and a y. The directions also say to bring this into Desmos. So in Desmos, you'd put in the first equation, 13x plus 12y equals 85, and then the next equation. And when you put them in, I have a picture here, their intersection point would be 1/6. So it's $1 per muffin and $6 for a pie. Okay. Again, we're going to solve some examples with elimination, and then after we're going to check our answers on Desmos. So here again, right, we want to be able to add. When we add positive x minus x, that gives us, that cancels out, and then we'll have a 5y equals 15. Then this is a one-step equation. We're going to divide each side by 5. Y is equal to 3. Now, I like things to be positive, so I'm going to pick the first equation. But you could pick either one. As long as you do your calculations accurately, then it won't matter. All right, so now I'm going to plug in y is equal to 3. So I have x plus 2 parentheses equals 2. I simplify the left. X plus 6 equals 2. And now I need to get x by itself. So I'm going to subtract 6 from each side, because what I do to one side, I have to do the other. And x equals -4. And are you ready? I'm going to take the second equation, because I've already used the first one. And I'm going to plug in -4. Now, really important that you're using your parentheses so you don't lose that negative sign. So -1 times 4, this is 4, plus 3y equals 13. Then it's a two-step equation. If I subtract 4 from each side, I'm going to get 3y equals 9. And when I divide by 3, I'm going to get y is equal to 3. And hence, my systems, the answer is -4, 3. And again, you should bring both those equations into Desmos and check your answer, and then you can check the box. Number 2, by looking at it, I can see the y's are going to cancel if I add these two equations. So I'm going to have 4x, these cancel, or equal 0, equals -20. I'm down to a one-step equation. I divide each side by 4 to get x by itself, and I have x is equal to -5. I'm going to take that information and I'm going to plug it in. I'm going to use the top equation because it's all positive mostly, except for the -31, eh? Okay, and I'm going to plug in -5 for x. Again, simplifying the left, -15 plus 2y equals -30. Coming down to a two-step equation, I'm going to add 15 to each side. And I'm going to get 2y equals 16, -16, -31 plus 15. And then I'm going to divide each side by 2, and y is equal to -8. Okay, so my solution, or my ordered pair, which is the solution, is -5, -8. And I took it into Desmos. As you can see, I took a screenshot of it. And they do connect at -5, -8. So I can check off my box. I checked it in Desmos. Okay. Problem 3. Same process. We're going to add. And 2 minus 2 plus -2 gives me 0. Then I have 8y equals 16. Voila, down to a one-step equation. Divide by 8, divide by 8. So y is equal to 2. Okay. Now again, I'm going to take the top equation because it's positive. I'm going to plug in 2 for y, and this is going to give me 2x plus 6 equals 6. Draw my line. Now I'm trying to isolate the variable, and I have a two-step equation, so I'm going to subtract 6 first. This positive 6 minus 6 is 0, so I'll have 2x is equal to 0, and I divide by 2, and 0 divided by 2 is 0, so x is equal to 0. So there's my ordered pair, or my solution, okay? X is equal to 0 and y is equal to 2. Again, I brought it into Desmos, as you can see right here. I took a screenshot, and that they do intersect at 0, 2. So I can check off that box. Okay, number 4. Oh, I can see that the y's are gonna cancel when I add. Okay, oops. So positive 5 plus a negative 12 is negative 7x. This would give me 0. 22 plus a negative 36, I end up subtracting, so that will give me a negative 14. Divide by negative 7. Oops. So x is equal to 2. So you eliminate by adding and wiping out one of the variables. Then you solve for that variable. Then you plug that variable back in to an original equation. Okay. 5 times 2 plus 4y equals 22. So then you simplify the left. I'll have 10 plus 4y equals 22. Then you're going to subtract 10, and you have 4y is equal to 12. And when you divide by 4, you get y is equal to 3. So my solution, or my ordered pair, is 2, 3. Again, bringing it into Desmos, and that's where it is. And in fact, I am correct that the solution is 2, 3. Okay, so if I look at number 5, if I add, I won't be able to wipe or eliminate any one of the variables. So I am going to multiply the top by a negative 1. Okay, so that would give me negative 5x minus 4y equals negative 6. And then I'm just going to rewrite the bottom equation. Now I have set myself up so that when I add these two equations, one of the variables will wipe out. So negative 5 plus 7 is 2x. Negative 4 plus 4 is 0. So that cancels. And then negative 6 plus 14 is 8. And then we're going to divide. Divide this side by 2. Divide this side by 2. X is equal to 4. Now I'm going to take this information and plug it into the second equation. And it won't really matter which one in this. They're both positive. As long as you do all your calculations correctly, you'll come out to the correct answer. I'm going to plug in, a 4. Okay. So 7 times 4 is 28. Plus 4y equals 14. So if I subtract 28 from each side, because what I do to one side I have to do to the other, I'm going to have 4y equals negative 14. And when I divide by 4, you could either write this as 4 negative 7 over 2, or 4 and negative 3 halves. Either one is fine. You can reduce the fraction or write it. And once again, I took my two equations, I put them in Desmos, and they check. Okay, last one. Let's make it a goodie. Okay, so we can, this one we cannot add to get either one of them to equal 0. So we have to multiply, I'm just going to multiply the top by a -1. So it's going to be -3x minus 2y equals a positive 31. Remember that you have to multiply everything through, kind of taking that -1 and distributing it. Now, I've set myself up in the right spot. I can add. This seems familiar. -3 plus 5, so that's 2x equals, these two cancel each other out, and 31 plus a -49, they're fighting forces because one's positive, one's negative. So if I subtract, I'm going to get a -18. And then I'm going to divide to get my variable by itself. X is equal to -9. Now, take that and plug that in. 3 times -9 plus 2y equals -31. Draw my line, simplify the left. -27 plus 2y equals -31. Add 27 each side. I'm still trying to isolate the y. I'll get 2y equals -31 plus 27 is a -4. And then you divide by 2. And you're going to get y is equal to -2. So my solution is -9, -2. Okay, oh, and I did. And I checked it out on Desmos, and it checked. That is the correct answer. Okay, any questions, just email your teachers. Thank you.